Hello guys, today we're doing question 141 of LeetCode, linked list cycle. The question is, given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is a some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tells the next pointer is connected to. Note that position is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So the example here is a linked list of 3, which links to 2, when next value is 0 and next value is -4, and -4's next value is 2. So the node of 2, we come across it twice, so the loop is here. The input head, as you can see here, is 3204, position is 1. This is the position that the loop iterates from. The output is true. There is a cycle in the linked list where the tail connects to the first node, 0 indexed. And as you can see, this example is similar, and this one returns false as there is no cycle. Now, a common way to do this is by using a set, which I'll walk you through first, but there is a much better way to do this, which I'll show you after the first example. So here we have a linked list. So what we do is we create a set, and every time we visit a node, we add it to the set. And we check if that node has been added to the set. If we find it, we return true, because we found a loop. Otherwise, we return false. But let's change the set with a name to visited. So here we have a visited set. Visited here, and so now we create a while loop. So while node next is not equal to null, we keep iterating. So here we're at 3. It's 3 visited no, so we set that in the set. Go to the next value. Now we're at 2. It's 2 visited no, set to the set. Go to the next value. We're at 0. It's 0 visited no, set to the set. Go to 4, -4. It's -4 visited no, we add it to the set. Go to node the next. Now we're at 2. It's 2 visited. Yes, so we return true. Now, if -4 had another value that was null, as not node the next, we'll break the loop and we return false. Let me show you how we do this here. So the first thing we do is we create a set. So let visited is equal to new set. Then we loop through the head, the list. We loop through the linked list starting from head, as long as head doesn't equal to null. Then we check if visited dot has current head, then we know we've found the loop, so we return true. Else we add to visited to the set the current node, and then we set the node to the next value, so we don't iterate through an endless loop of the same node. Now if we do pass the while loop, we know there is no loop, so return false. Now let's see if that passes. That does. Let's submit. As you can see, this is a time complexity of ON and a space complexity of ON as well, because we're storing each value and we're looping for each value in the list. But as you can see here, the space complexity is very bad. It only beats 5%. Now we'll show you how to improve it, how to beat most people. And the way we'll do that is by changing the node's value in place. So I'll show you an example here. So let's say we have the linked list here. What we do is, every time we visit a value, we change the nodes. Every time we visit a node, we change the value to a string of visited, so we know we've come across that node already. This way we don't have to store any extra space. So let's say we start from here. We check if that node is equal to visited. It's not. So we change the value to visited. We put a V to represent visited. And we go to the next value. We're now at 2. It's 2. Has this node got value of visited? No. Set its value of visited, we go to the next value. Now we're here. Does this node has value of visited? No. So we set this value to visited. We go to the next value. Does this node have value of visited? No. Set this value of visited. We go to the next value. Does this node have value of visited? Yes. That means we found the loop, so we return true. Again, if one of the nodes next value return a null, that means we've reached the end of the list and we return false. So let me show you how we would do this. So we wouldn't need to, let me just scrap the code. So we just start a while loop straight away. While we have a head, we continue. While we have a node, we continue. Then we check if the head or the node's value is equal to visited, then we return true. Else we set the node's value, so head val to visited to represent that we've been here already, and then we increment the head to the next value. And if we've looped through the whole list, again, we haven't found a loop, so we'll return false. Now, let's see if this passes. It does. Now I want you to look at the difference in terms of memory. The time complexity will be the same as we're looping through the whole list anyway, but look at the space complexity here. As you can see, this has greatly increased. We now beat 72% rather than 5%. Reason being, we don't have to store the whole linked list in a set. We don't store any value at all, in fact. So it's just a time complexity of O1 compared to the previous one of ON. Thanks for watching.